On a live construction site, the environment never stands still. Machines operate. Structures vibrate. Sound travels far beyond the boundary fence. When noise and vibration exceed permitted limits, the consequences are real. Stop work orders, community complaints, structural damage, regulatory breaches. This is video 4 of the Site Environmental Compliance Masterclass. Noise and Vibration Monitoring, your field compliance guide. Let's get into it.
Here is what we are covering today. First, why noise and vibration monitoring matters and what happens when it goes wrong. Second, the regulatory frameworks and the limit values you need to know. Third, the equipment you will use in the field. Fourth, how to select monitoring locations correctly. Fifth, the step-by-step field monitoring protocol. Sixth, data recording and reporting requirements. Seventh, exceedance management and non-conformance reporting. And eighth, the control measures and best practices that separate compliant teams from the rest. Let us begin. By the end of this training, you will be able to do 6 things. 1. Understand noise and vibration limit values, IFC EHS Guidelines, ISO standards, BS 5228, and your project-specific consent conditions. 2. Select the correct monitoring equipment and calibrate it properly before every session. 3. Plan and execute a fully compliant field monitoring program. 4. Record, report, and submit monitoring data to a professional standard. 5. Manage exceedances, issue the NCR, notify the right people, control the source, remonitor, and close it out. And 6. Apply the noise and vibration control measures that actually work on active construction sites. These are real competencies, field applicable from day one. Before we go into the technical detail, let us be clear about what is at stake. Noise above 85 decibels A-weighted causes permanent hearing damage in construction workers. This is occupational health, not just compliance. Community noise complaints do not stay at the complaint level. They escalate. Regulators get involved. In serious cases, works stop. Vibration from piling, blasting, and compaction can crack walls and damage buried utilities, long before the levels are obvious. Regulatory breaches trigger non-conformance reports, stop work orders, and financial penalties, all of which land on your project record. And from an ESG perspective, non-compliance with environmental limits is reportable. Investors and clients see it. Proactive monitoring is your evidence of due diligence. Under ISO 14001 and IFC EHS Guidelines, documented monitoring is expected, not optional. This is not about paperwork. This is about protecting people, projects, and communities. The regulatory framework for noise and vibration monitoring operates as a hierarchy. At the international level, the IFC Environmental, Health, and Safety Guidelines from 2007 set the reference point for most major infrastructure projects. The key daytime limit for sensitive receptors is 55 decibels A-weighted. Nighttime is 45. WHO Community Noise Guidelines inform those IFC values and provide receptor-specific reference levels. At the technical standards level, ISO 9612 governs occupational noise exposure measurement. ISO 4866 and BS 7385 address structural vibration. And BS 5228 Parts 1 and 2 provide specific guidance for noise and vibration control on construction and open sites. National authority requirements sit below that, local environmental regulations and noise bylaws that vary by jurisdiction. And at project level, your construction environmental and social management plan, your client specifications, and your consent conditions may impose limits more stringent than any of the above. Always verify. The most restrictive applicable limit is the one you must meet. Key occupational exposure action level, 85 decibels A-weighted, 8-hour equivalent. Peak sound pressure, 140 decibels C-weighted. PPV for residential structures, 2 to 5 millimeters per second. Your field toolkit for noise and vibration compliance monitoring has 6 essential components. First, the sound level meter, Class 1 Precision, IEC 61672 compliant. This is the only standard acceptable for regulatory compliance monitoring. It records LAeq, LAmax, LA90, and LCpeak, the full range of parameters you will need. Second, the vibration meter, or geophone. This measures ground-borne vibration in terms of peak particle velocity in millimeters per second, essential for pile driving, blasting, and vibratory compaction operations. Third, the data logger. For any monitoring that runs unattended over 24 to 72 hours, nights, weekends, continuous operations, a calibrated data logger is required. Fourth, the acoustic calibrator, IEC 60942 standard. You will use this before and after every single monitoring session, without exception. Both calibration records are part of your audit trail. Fifth, the windshield and weather shield. Outdoor monitoring without a windshield produces false readings. It is non-negotiable. And sixth, the tripod. Standard height is 1.2 to 1.5 meters above ground level, positioned away from large reflective surfaces as specified in BS 5228 Annex E. The right equipment, correctly deployed and calibrated. That is where compliant monitoring starts.
Where you place your monitor determines whether your data is valid. This is a technical discipline. Start by identifying all sensitive receptors within the zone of influence: residential areas, schools, hospitals, places of worship, and any receptor specifically identified in your consent conditions. Place your monitor at the site boundary point closest to that receptor. This is the nearest facade rule, the measurement point that gives the most representative result for the receptor's exposure. Maintain a minimum clearance of 3.5 meters from any large reflective surface. Walls, solid hoardings, and building facades all create acoustic reflections that bias your readings. Height: minimum 1.2 meters above ground level. Never mount the meter directly on a structure or a hoarding. That compromises the measurement. Every designated monitoring point must be documented with GPS coordinates, a photograph of the setup, and a site sketch showing the point relative to the boundary and the receptor. This is your audit trail. And critically, before any construction activities commence, you must establish a pre-construction ambient baseline. Without a baseline, you cannot demonstrate the contribution of construction to the receiving environment. Location selection is not guesswork. It is technical, documented, and defensible. Here is the exact sequence for conducting a compliant noise monitoring session. Step 1. Pre-session setup. Perform acoustic calibration of the meter. Record the calibration reading in your field log. Check the battery level and firmware. Confirm that weather conditions are within acceptable parameters. Wind speed should be below 5 meters per second for outdoor monitoring. Step 2. Positioning. Place the meter at the designated monitoring point, confirmed by GPS coordinates and cross-referenced against your approved monitoring plan. Step 3. The measurement run. A minimum of 15 minutes of continuous LAeq measurement is required per BS 5228 and IFC EHS guidance. During this entire window, you are recording every noise-generating activity on site. That source log is as important as the reading itself. Step 4. Record activities. Document everything active during the measurement window: plant types, operations in progress, distances from the monitoring point. If you cannot explain the reading, the data has reduced value. Step 5. Post-session calibration check. Immediately after the monitoring period, recalibrate the meter. If the calibration drift exceeds the manufacturer's specification, the session data may need to be flagged. Step 6. Data download and transfer. Upload readings to your monitoring register, complete the datasheet, and prepare for reporting. 6 steps. Every session. No shortcuts. Noise monitoring generates multiple data parameters, and you need to understand what each one means. LAeq, the equivalent continuous noise level averaged over your measurement period. This is your primary compliance metric. This is what you compare against the regulatory limits. LAmax, the maximum instantaneous A-weighted sound level recorded during the monitoring period, used to identify peak events. LA90, the background noise level exceeded for 90% of the measurement duration. This represents the ambient environment without the dominant construction noise sources. LCpeak, the peak C-weighted level, used for impulsive noise assessment and structural vibration reference. Beyond the acoustic readings, your field log must capture date, start time, end time, weather conditions, including temperature, wind speed and direction, and cloud cover. Each of these affects your readings and may be relevant in any subsequent review. Photograph the equipment setup at each session. Photograph the receptor facade. Document site conditions. All readings are compared against the applicable limits in your monitoring plan. Any exceedance is flagged immediately, not at the end of the week. Weekly monitoring reports go to your project environmental management team and the client environmental representative. Raw data, calibration certificates, field sheets, and photographs, all retained. These form your audit trail. If it is not documented, it did not happen.
When your monitoring returns a reading above the applicable limit, you respond immediately. Every step of this process is time critical. Step 1. Detect. The exceedance is identified during the monitoring session or on data review. Do not wait. Step 2. Investigate. Identify the source. Which activity, which plant type, which location on site is generating the exceedance. Document it. Step 3. Issue the non-conformance report. The NCR is raised the same day. It captures the source, the time, the receptor, the measured level, and photographic evidence of the conditions. Step 4. Notify. The project manager and the client environmental representative are notified within 24 hours of detection. No exceptions. Step 5. Control. An immediate corrective action is implemented. That might mean shutting down the offending plant, installing temporary acoustic screening, or restricting operations to consented daytime hours only. Step 6. Remonitor. Within 48 hours of implementing the control measure, you return to the monitoring point and conduct a full session to verify that the exceedance has been resolved. Step 7. Close the NCR. Only when a verification measurement confirms full return to compliance does the NCR get closed. Documented, signed, and filed. 7 steps. Non-negotiable. This is how professional teams manage exceedances. When monitoring tells you there is a problem, or before there is a problem, these are the engineering controls that work. Acoustic barriers and hoardings. A solid hoarding at the site boundary, minimum 4 meters high, provides meaningful noise reduction from the mass law. The higher and more massive the barrier, the greater the insertion loss. Equipment selection. Specify low-noise plant at the procurement and tender stage. Reference ISO 4871 declared sound power levels when selecting between options. The quieter machine is often the same price. Operational scheduling. Restrict percussive works, concrete breaking, and any high-noise operation to the consented daytime hours defined in your consent conditions and your CESMP. Document the schedule and enforce it. Silencers and mufflers. Every generator, compressor, and diesel-powered plant on your site should have an effective silencer or muffler. Inspect them weekly. Degraded silencers can raise sound levels by 10 decibels or more. Distance management. The inverse square law means that doubling the distance from a noise source reduces levels by approximately 6 decibels. On a busy site, even moving operations 20 meters further from a receptor makes a measurable difference. And community liaison. Issue advance notice to sensitive receptors before any high-noise operation. 48 hours minimum. A phone call or letter to a neighboring resident or building manager can prevent a formal complaint that goes to the regulator. These are not theoretical controls. They are deployable, measurable, and effective.
Vibration from construction is not a secondary concern. It is a primary compliance obligation, and one that is frequently under-resourced.
Before any pile driving, dynamic compaction, blasting, or vibratory roller operations commence, you must conduct a pre-construction structural condition survey. Every building within the confirmed zone of influence, documented, photographed, baseline established. Vibration trigger levels are established at the start. These are the thresholds at which you stop operations, investigate, and report. For residential structures, BS 7385 and ISO 4866 guide values are typically in the range of 2 to 5 millimeters per second peak particle velocity, but your project-specific values may be set lower by consent conditions or client requirements. Before full-scale vibratory compaction begins, run trial passes with a geophone in place. Measure the actual PPV at the nearest structure before committing to the full operation. When a geophone alarm triggers, operations stop immediately. Not at the end of the shift, immediately. The event is documented, the cause is investigated, and the project team is notified. And once construction is complete, a post-construction structural condition survey confirms that no vibration-induced damage has occurred during the works. Geophones, PPV trigger levels, condition surveys, trial passes. These are not optional extras. They are your structural protection program.
These are the practices that separate teams that manage noise and vibration compliance from teams that merely respond to it. First, calibrate every session, pre and post, without exception. Skipping one calibration can invalidate an entire data set in a regulatory review. It takes 2 minutes. There is no excuse. Second, monitor continuously during high-risk works. Spot checks are insufficient for pile driving, blasting, or vibratory compaction. Continuous monitoring data tells the full story, including what happened at 11 p.m. on a Saturday. Third, maintain a live monitoring register, updated after every session, with timestamp, reading, weather, source log, and calibration reference. When the auditor arrives, your register should be current. Fourth, build community liaison into your environmental management plan. Proactive communication prevents complaints from becoming formal notifications. A complaining neighbor who has been briefed in advance is a very different situation from one who finds out through the regulator. Fifth, activate your CESMP-aligned monitoring schedule from day 1 of site mobilization. Not after the first exceedance, not after the first complaint. Day 1. And sixth, link your monitoring results to your ISO 14001 environmental objectives. Monitoring data is evidence for your environmental management system, your management review, and your internal audit program. This is the operational standard. It is achievable, and it protects your project. These are the mistakes that show up on real sites and the fixes that eliminate them. Skipping calibration before monitoring. Both pre- and post-calibration are mandatory under IEC 60942. If you only calibrate at the start, your post-session drift is unverified and the data is potentially invalid. Placing the monitor next to a reflective wall. A meter within 3.5 meters of a solid wall is measuring reflections, not the direct sound field. Check your placement before starting the session. Monitoring only during quiet periods. If your monitoring sessions always happen to avoid the noisy operations, that is not compliance monitoring. Monitor during active high-noise works. That is the requirement. Failing to log sources during the measurement. The reading means nothing without knowing what was generating it. The source log is mandatory. Delaying the NCR after an exceedance. The 24-hour notification rule is not a target. It is a deadline. The NCR is raised the same day. If you wait until the weekly report, you have already failed. And starting construction without a baseline. Without a pre-construction ambient baseline, you cannot quantify your construction contribution, you cannot demonstrate compliance, and you have no reference for any future dispute. Know the mistakes, apply the fixes. Do not let these appear in your monitoring records. 6 things to carry into the field from today. Know your limits. IFC EHS, BS 5228, and your project consent conditions are your compliance reference. Know them before you deploy. Class 1 equipment only.
and calibrate it before and after every single session. This is non-negotiable. Place your monitors correctly. Site boundary, 1.2 meters above ground, 3.5 meters from reflective surfaces. Every session, every time. Document everything. The reading, the sources, the weather, the calibration records, the photographs. If it is not in the record, it did not happen. When limits are exceeded, act immediately. NCR the same day. Notify within 24 hours. Implement controls. Remonitor within 48 hours. Close the NCR with verified evidence. And treat vibration as seriously as noise. Structural condition surveys, PPV trigger levels, geophone monitoring, trial passes, all mandatory before high vibration operations begin. You now have the complete field compliance framework for noise and vibration monitoring. Apply it on site. Protect your project, protect your community. I will see you in the next video.
This is EnviroVerge, environmental knowledge field ready. If this training gave you something practical, subscribe. We post field-ready environmental training every week. Playlist 1, the Site Environmental Compliance Masterclass, continues with Video 05 next. If you have questions about noise and vibration monitoring on your project, drop them in the comments. I read every one. Take care of your projects, your communities, and your teams. I will see you on site.